So in the previous class, we see Young's modulus, bulk modulus, modulus of rigidity. At the same time, we know now stress, we know strain, we know long three type of strain is there: longitudinal strain, shearing strain, volumetric strain, and shearing strain. Two type of stress is there, mainly normal stress and the tangential stress or shearing stress. Now, the ratio of the stress by strain is called the modulus of elasticity. Now, modulus of elasticity is three types. One is the Young's modulus, one is the bulk modulus, one is the modulus of rigidity. Young's modulus, what happened? Just force applied per unit length, that is normal to the surface, and the change in length, the original length, that is longitudinal. In volumetric strain, what happened? Change in force per unit area, and change in volume by original volume. Force per unit area is the stress, and change in volume per unit volume is the strain. And pressure and volume are inversely proportional. So if one is positive, another one is negative. So we take a negative sign, del P by del P by del V by V, that is minus V del P by del V. And the last one is modulus of rigidity. So in modulus of rigidity, tangential stress applied. Okay, tangential stress applied. So force per unit area by this angle. Now here one more thing that is called the compressibility. Compressibility is defined as inverse of bulk modulus. We can write minus 1 by V dV by dV, that is my compressibility. So after that, let's try some numerical related to this topic. Question number 1, see. The question is that a structure of steel has a radii of 10 millimeter. Structure of steel has a radius of 10 millimeter and length 1 meter. 100 kilonewton. 100 kilonewton force stretches along its length. Calculate number 1, stress. So we know stress equals to force per unit area, that is 10 to the power 5 by area is pi r square, that is 10 to the power 5 by 22 by 7 into radius is 10 millimeter, that means 10 to the power minus 2 whole square. And after solving this, we get 7 by 22 into 10 to the power 9 Newton per meter square. And the second part of the question is elongation. Number 3, strain. Young's modulus is given 2 into 10 to the power 11 Newton per meter square. So we know why force per unit area by change in length by original length. So force length change in area into del L. So what we have to find out in the question number 2, we have to find out the elongation. How we get the elongation? Force length YA. Now we can easily put the values. Force is 10 to the power 5 length is given 1 meter, y is given 2 into 10 to the power 11, area is given 22 by 7 into 10 to the power minus 4. And after solving all this, we get 7 by 44, 10 to the power 9 optional part of the 7, 10 to the power 5 minus 10 to the power 7. So 7 by 44 into 10 to the power minus 2, which is nearly equals to 0.159. And the third part of the question is strain. So for strain, change in length by original length, that is 1.59 into 10 to the power minus 3 by 1, that is 1.59 into 10 to the power minus 3. No unit. Okay. Just 1 minute. Question number 2. See what happened in question number 2. The average depth of Indian Ocean is about depth. Indian Ocean is about 3000 meters. Calculate the fractional compression. Fractional compression del V by V. Compression itself a negative sign, that is compression. Compression. Fractional compression of del V by V of water at the bottom of the ocean, given that the bulk modulus of water is 2.2 into 10 to the power 9 Newton per meter square. So we know that P is the atmospheric pressure and this is the ocean, suppose. So depth of the water is 3000 meters. P is the atmospheric pressure. So pressure at the bottom, that is atmospheric plus pressure plus rho gh. So we know the formula bulk modulus is minus del P del V by V. So del P is the P minus P naught. So P naught plus rho gh minus P naught, that is rho gh. So minus rho gh by del P by V. And we have to find out the compression, that is del P by V with the minus sign rho gh by V. Now for water, SI unit 10 to the power 3, G is 10, H is 3000, and bulk modulus is how much given? 2.2 into 10 to the power 9. So what we have, 3 by 2.2 into 10 to the power 7 minus 9. That is almost 1.3 divided by 2.2 has how much? 1.36, or you can say 1.37. 1.37. Yeah, 36. So 1.36 into 10 to the power minus 2, that means 0.136 into 10 to the power minus 3. So this is the question number 2. Again, unitless quantity because compress del V by V is a ratio. Now I just want to show you question number 3. Related to shearing strength. Lead square slab of side 50 centimeter like this, 50 centimeters. So this is 50 centimeter. This one is 50 centimeter. And thickness 10 centimeters. So I can say this is 10 centimeters. Thickness 10 centimeter is subjected to a shearing force on its narrow face. Narrow face means this is my narrow face. So I'm applying the force in the narrow face of 9 into 10 to the power 4 Newton. The lower edge is the lower edge riveted to the floor. So these are the lower edge. Riveted to the floor. How much will the upper edge be displaced? That means my main aim due to this force applied, as the lower one is fixed, so it will be moved like this. So this angle is theta. This is the shift which we find out. How much will the upper edge be displaced? So we have to find out this x. So before we start this x, here it is given theta, that is coefficient of viscosity 5.6. Sorry, modulus of rigidity 5.6 into 10 to the power 9 Newton per meter square. So we know this one is force per unit tangential area into theta. So if I want to calculate theta, my formula is force area theta, and this theta is what? X by L. So later on I can put and find out the value of x, or here also you can directly put force L A theta. Force is how much? 9 10 to the 4. L is how much? 50 centimeter, 0.5. A is how much? This area. So 0.5 into 0.1. Theta is how much? 5.6 into 10 to the power 9. So after solving all this value, you get 1.6 into 10 to the power minus 4. As it is length x, so the value is in centimeter. Sorry, this one is in meter. Yeah, 0.16. Zero 0.16 into 10 to the power minus 3 meter. Yeah, 0.16. Is it okay, everyone?
Yes, sir.
So after this, these are the 3 questions related to your this Young's modulus, bulk modulus, and modulus of rigidity, and then sharing stress and strain, all these related questions. Now, one more thing which is very, very important, that is elastic potential energy. So for this elastic potential energy, you have a rod. This length is L, and by applying force, you stretch it with a distance of del L. F is the force applied. So we know work done. Work done is equal to, the definition of work done is average force into elongation. What do you mean by average force? Initial force plus final force by 2. Now the initial, no elongation is there, 0. So final force by 2 into del L. So what is my final force? Final force is let F. So we can write half force into elongation is my work. Now once I get this one, the work done is this half force into elongation. So we can say this work done stored as a potential energy. So potential energy, that is U half force into elongation. Sometimes this is also called half load into elongation. Now, the next part is energy density. That's energy stored per unit volume. So half F into del L by area into length. So that means half force per unit area change in length by original length. So what you have, half stress into strain. That is also very, very important, and that is energy density. And what do you mean by energy density? Energy density is energy stored per unit volume. So you can convert this also. Second thing is that we know Y is stress by strain. So we can say stress is Y into strain. So we can write Y into. So it's depend on the situation. What is given. বাবা রেকর্ডিং করতে ভুলে গেছিলাম। এই হচ্ছে হ্যালো। So same way, the second part of the question, what is given in the second part? See, equal stress, equal strain. So as the strain is equal, so what we can write? We can write strain of steel is equals to strain of brass. Now we know Young's modulus, that is stress we know Young's modulus, that is stress by strain. So strain is stress by Young's modulus. So we can write stress by Young's modulus of steel, that stress by Young's modulus of the brass. Now we know that from here, stress means tension of the steel, area of the steel, Young's modulus of steel, tension of brass, area of brass, Young's modulus of brass. So tension of steel by tension of brass, that is area of steel, area of brass into Young's modulus of steel, Young's modulus of brass. Now in this question, if I see, okay, missed to give you. खुले लिखने लिखते So one more thing is given. Forget to write this. It is given Young's modulus of steel and Young's modulus of brass. Young's modulus of steel is given. Young's modulus of steel is given 2 into 10 to the power 11 Newton per meter square, and Young's modulus of brass is given 1 into 10 to the power 11 Newton per meter square. So if I use this two value, what happened? Area is given. Steel का कितना area था? Steel का area था 0.1 and brass का area था 0.2. Young's modulus of steel is 2 into 10 to the power 11, area था 1 into 10 to the power. So if I cancel them, so what we have 1. That means tension of steel is equals to tension of brass. Now if we use this one in the same second question, this equation. So tension of steel into X, tension of steel into X, that is tension of brass. Brass is equals to steel 2 minus X. I can cancel this from that what we have 2x equals to 2, x is equals to 1 meter. So at the middle, because the ratio is same. Okay, everyone?
Yes, sir.
After that, last topic related to this chapter, that is Poisson's ratio. Poisson's ratio. So what is Poisson's ratio? Poisson's ratio is the lateral strain by longitudinal strain is represented by the symbol is lateral strain by longitudinal strain. That means suppose we have a cylinder whose length is L, diameter is D. Now suppose I am decrease its diameter by stretching. So obviously my length increase. Yes or no? Hello.
Yes, sir.
So my change in diameter D become D minus D del D. So I can write change in diameter by original diameter by change in length by original length. And one more thing I can notice here, if my diameter is increasing, that means length is decreasing. If my diameter is decreasing, then length is increasing. Then again they are, one is increasing, one is decreasing. So I put a negative sign. Because this is a ratio, so ratio is always a positive value. So this Poisson's ratio is the formula of this. Now, with related to this, a very lovely question is there. Question is, determine the Poisson's ratio of a material of a wire. Determine the Poisson's ratio of a material of a wire whose volume remain constant. Volume remain constant. Determine the Poisson's ratio of a material of a wire. So what do you mean by wire? I just help you. A wire means you have a length as well as you have a diameter. So determine the Poisson's ratio of the material of the wire whose volume remain constant. ये wire का volume constant है under an external normal stress. Means you are applying the normal stress. So find out the Poisson's ratio of this. Try this question. I'll give you 2 minutes for that. Anyone tell me? देखो, we know volume equals to pi by 4 d square into L. So if we differentiate this, as the volume is constant, the differentiation of volume is 0. 4 by pi by 4 you can take common. Now here you have d square and L, both can be variable. So we can differentiate this. So what we have, 2 diameter, you can write capital D, it will be better. Otherwise you are confused. So 2D, then this one, keeping L constant, plus keeping D constant, we differentiate L, and that is equals to 0. That means 2D, this into L is minus D square DL. I can cancel 1D. So negative sign D by D, if you move this side, you have 1 by 2 DL by L. That means minus del D by D by del L by L is equals to half. That is 0.5. So the option is your Poisson's ratio is 0.5. Okay, everyone. Hello. Is it okay? Everyone, is it okay? Hello. Acha. So then, Rohit, বুঝতে পারলি?
Yes, sir.
So after that, this chapter is, you can say, complete. So we can start a new chapter, that is oscillation and waves. In this oscillation and wave, first we start simple harmonic motion. So see, we all know some definitions like what is periodic motion. If in a after a particular interval of time, if a particle repeats its motion, then it is called periodic motion. Oscillation means if a particle moves to and from motion, it's with respect to its mean position, then it is called oscillatory motion. What do you mean by simple harmonic motion? If a particle moves to and from motion with respect to oscillation, and here is a usually what happened in simple harmonic motion. Hey, Pluto, acceleration is directly proportional to elongation. Acceleration is directly proportional to elongation, and this acceleration, when you equalize like d square x by dt square, when you equalize, we use a constant with a negative sign. That means, what do you mean by negative sign? The acceleration always oppose the direction of motion. Is it clear, everyone?
Yes, sir.
So this is a very vital formula, or you can say this is the only formula if you're able to remember. D square x by dt square plus omega square x equals to 0. This is one formula in terms of displacement, and sometimes the same formula we use in terms of angular displacement. So we can use d square theta by dt square plus omega square theta equals to 0. So these are the two very vital formula from where mainly in this chapter, this SHM, simple harmonic motion, mainly the question they give you, either find out the time period or find out the frequency. So time period is 2 pi by omega, and frequency is 1 by time period, that is omega by 2 pi. So my main aim, first to give, according to condition, we have to make this in this form, and after we get this form, from this form we can find out the omega. Once we find out the omega, we can easily find out the time period, and on that basis we can find out time period or frequency. That is the main thing. The question for ध्यान से देखो, and then we try some numerical. First of all, see, suppose number one is spring. So in spring we know, suppose this is my spring, this is the initial position, x equals to 0. Now see, if we elongate it up to here, suppose the x is the elongation, so tendency of motion is in opposite direction, so they are opposing each other. So we can say spring force, that is minus k into x. We all know that this negative means opposition. Spring force always oppose the elongation or displacement, and this force equals to mass into acceleration. So I can say acceleration, that is d square x by dt square, that is minus k by mx. So देखो, my main aim, always my main aim, to convert them in this two form. Acha, one more very important. If we try to find out in this form, means in the displacement form, so we use the force, and if we try to find out in the angular form, we use the concept of torque. So if you kept in mind that part, so you can easily solve this type of question. Obviously depend on the situation. Like here, d square x by dt square. So what we have, d square x by dt square plus k by mx equals to 0, which means my omega is root under k by m, time period 2 pi by omega, that is 2 pi m by k. Okay, everyone. So this is also a very, very important information you always frequently use. Now see, once you know this one, now we already know spring from the chapter work power energy. I just want to give you one example, then you understand. If you know the spring constant, you can easily find out the frequency or time period of oscillation. Suppose this is my question, mass, and I can move in this side. And in this question, suppose this is 4K, 4K, 3K, 2K, 2K, 5K, 6K, 6K, and this is 2K. Question is find the time period. So obviously my main aim to find out K equivalent, we know this two are in series, so 2K. So here you can write these two are in series, so we can write 2K. So these are in parallel, and they here you have 2K, 3K, and here you have 2K, 2K, K. So what is your equivalent spring constant? 2K plus 3K plus K plus 5K plus 3K plus 2K. So what you have? 3 2 5 আর 1 6 6 7 8 9 10 11 12 13 14 15 16 16K. Yes or no? শ্রাবণী বুঝতে পারছিস?
Yes, sir.
So once you get the time equivalent spring constant, you can easily find out the time period. That is 2 pi root under m by 16K. That means sometime it will be like 2 pi by 4 m by k, pi by 2 m by k. Okay. Yes.
Yes, sir.
Next. Okay, now see, so similarly I can show you some questions where we can find out the spring constant. Next question. Like the question is that suppose this is a liquid, density of the liquid is rho. A cylinder is floating here. Mass of the cylinder is m. So what do you mean by floating? They balancing each other. Now by using force, you suppose push it some distance x. X is very, very less. So as you are pushing it towards the liquid, so what happened? Volume inside the liquid increase. So up first apply yes or no?
Yes, sir.
So what we can say? Key thrust. We know the value of thrust. Rho GV, and which is opposing the motion, because if the x is moving downward, then what happened? If thrust is acting upward. Now if it is moving upward, then the volume inside is less than weight, so it will be moving downward, so opposite. So m is the mass of the cylinder into acceleration minus rho g volume. What do you mean by volume? So volume, for this volume they give you the area of the cylinder. So area of the cylinder into x, which you imagine. So acceleration d square x by dt square, that is minus rho g a by m x. So my main aim to convert it in that form. Once you get this, so omega is root under rho g a by m. So my time period is 2 pi by omega, 2 pi root under m by rho g a. Yes, everyone?
স্যার
Ah,
উপরে যে ইকুইভ্যালেন্ট ওই যে স্প্রিং কনস্ট্যান্টটা বের করলে না, ওটা একবার বলো না।
কেন এটা তো আগেই করেছিলাম না, এই দুটো সিরিজ, এই দুটো সিরিজ, এই দুটো সিরিজ, তারপরে পুরোটা প্যারালাল, এই পুরোটা প্যারালাল, এরা দুজন প্যারালাল।
আচ্ছা স্যার, উপরের দুটো তো প্যারালালে আছে, তো প্রথমে প্যারালাল গুলো সলভ করে তারপর লাস্টে সিরিজ করলে আনসার কি সেম আসবে?
এই দুটো সিরিজ, এই দুটো সিরিজ, তাহলে এই তিনটে প্যারালাল, এই দুটো সিরিজ, তারপরে এই তিনটে প্যারালাল, তারপরে এই দুটো প্যারালাল।
তো কোন দুটো সিরিজ বললে?
আরে এই দুটো সিরিজ না,
হ্যাঁ হ্যাঁ
এই দুটো সিরিজ,
হ্যাঁ
এই দুটো সিরিজ,
হ্যাঁ,
বাকি সব প্যারালাল।
মানে সবকটাই প্যারালাল?
আরে এই দুটো সিরিজ হওয়ার পরে যে ভ্যালুটা আসলো সেটার সঙ্গে এটা প্যারালাল না?
আচ্ছা,
সব সলভ টলভ করে এখন এইভাবে বলছিস? আচ্ছা,
আমার আনসার আলাদা আসছিল তাই।
এটা 2k, এবার বুঝতে পারলে এই তিনটে প্যারালাল হবে তো?
হ্যাঁ
এই তিনটে প্যারালাল হবে তো?
হ্যাঁ স্যার বুঝেছি, সেম ইলংগেশন হবে তার জন্য না প্যারালাল সবকটা।
এবার এই দুটো প্যারালাল। Okay,
ইয়েস স্যার।
now see, so they can give you this type of questions also. Next question, like they can give you a U-shaped tube. And this tube, suppose liquids are there. Initially, this is the liquid, and it's a little bit curved, not straight. Huh? It's थोड़ा सा curve है, semicircular curve, means the curve is such a way that कि ये ground से हम लोग लेता है distance. Huh? So from this length is L from both sides, and A is the cross-sectional area of the tube. Now what happened is, suppose you are moving this downward with some x distance. So this one is moving upward, yes or no?
Yes sir.
And when you release this, it will be moving to and fro motion. So we have to find out the time period of oscillation. So see, very simple. Key mass and acceleration, that is minus. Let rho is the density of the liquid. So rho g v. So rho g volume. What do you mean by volume? A is the area, and the difference between this one and this one is how much? 2x. So I can write 2x. Similarly, for mass, same liquid is applied. So we can write rho volume. Volume is area into this side and this side L. So 2L into this square x. So I can cancel this 2 first. I can cancel this area. I can cancel this rho. So what we have, d square x by dt square equals to minus gx by L. So again, from that is very clear, omega is root under g by L. So your time period of oscillation, the time period of oscillation 2 pi by omega 2 pi root under L by G. Next type of question, suppose Earth is a solid sphere and from the center we make a tunnel. Mass of the Earth is m, radius of the Earth is r. Now suppose we put a ball very near to the surface of Earth. So what happens? It will become simple harmonic motion. Why? At here it will try to attract at the center. The gravitation is 0, but due to motion inertia, it will be moving this side. Once it moves in this side, the gravitation is opposite direction, so it will move in to and fro motion. So what happened? Suppose I am taking this is as a distance. I hope you remember the gravitation at a depth. So what happened in gravitation at a depth? Gravitation at a depth is g, which I can write the acceleration depth. The formula is g m dash by, here in place of r you can write x square. Yes or no? In the depth one we use at a depth d. So r is capital R minus d. Hope you remember. So here in place of r I write x because I am taking here x, and it is opposing. So and as it is opposing, I can use here a negative sign. Now my first aim to find out m dash, total mass by total volume, 4 by 3 pi r cube into volume of the shaded portion, this shaded portion, 4 by 3 pi x cube. So 4 by 3 cancel. M r cube x cube, I can put it here. So acceleration, which is d square x by dt square. Acceleration due to gravity is also acceleration g m by r cube into x cube by x square. 1x cancel. We have g m by r cube into x is the, see again you get this one. And if you remember, that is inside the normal formula is gm by r cube into r, and that's why you remember we take inside then outside gravitation. So if this is your answer, so we can easily say this is my omega root under gm by r cube. So time period 2 pi by omega 2 pi root under r cube by gm. So in that process, you can find out oscillation, simple harmonic motion. Next is the pendulum. Pendulum. So in case of pendulum, suppose this is the initial position, this is the final position, mg is acting downward. This angle is theta, this angle is theta, mg cos theta, this is mg sin theta. This is a very small distance, x. So first of all, the tendency of motion upward and the velocity is downward, force is downward. So minus mg sin theta. Theta is very, very small. So we can say force equals to minus mg theta. Now as the theta is very, very small, this is length and this is x. So I can say theta is x by L. So if we put it mass d square x by dt square, that is minus mg x by L. Cancel. D square x by dt square minus g by L x. So omega root under g by L. time period 2 pi by omega 2 pi root under L by G. Yes or no? I can solve this one by another method. This is called the method 2, which is also very, very important, especially in terms of entrance exam. I'm not solve it by using the force. I'm trying to solve it by the torque method. So let's see what happens if we use the torque method. Theta perpendicular distance. And this is length L. So I can say my torque, that is force into perpendicular distance, so mg sine theta into L. That is mg L sine theta. For very small angle, for very, very small angle, torque is mg L theta. Let it be the equation. And whenever you have simple harmonic motion, that means, and you want to solve it in terms of torque. So torque and restoring torque apply. Like if you remember moving coil galvanometer. In moving coil galvanometer also, at the bottom a spring is connected, which is restored. So restoring torque is there. So always with the torque, a restoring torque is there to regain its original position. This restoring torque is always in terms of when you have a theta. If it is not a spring, because here it's no spring is there. So moment of inertia into angular acceleration. So what do you mean by angular acceleration? D squared theta by dt square. So at any position, torque and restoring torque are equalized, or you can say the net torque is 0. So as I say, net torque is 0. So my torque plus restoring torque equals to 0. So mg L theta plus I d squared theta by dt square equals to 0. I d squared theta by dt square minus mg L theta, which means d squared theta by dt square minus mg L by I into theta. So we can use this formula, and this is valid for any type of pendulum, like simple or compound. If you use this formula, I just show you. So omega is root under mg L by I. So time period 2 pi by omega. I by mg L. Now see what happened. Now here in this question, means if you have a complex pendulum, so your moment of inertia is different. Here it's a simple above point mass, and this is the point of suspension. Length is L. So I can use moment of inertia is, especially here, the moment of inertia is ml square. If we put it, so 2 pi by omega, na? 2 pi is there. 2 pi ml square by mgl. So 2 pi root under L by G. You get the answers? Check. Same answer now. Now this one we can suppose it as a complex pendulum also. If we suppose a complex pendulum, what do you mean by complex pendulum? I can hang anything and I can rotate anything. So then this is the point of suspension, and this is the center of mass. Very, very important. Center of mass, and this is the point of suspension. So if it is a complex pendulum, everything is same. So where we just remember this formula. I just forgot. Moment of inertia about point of suspension. And L is the length between point of suspension and center of mass. I just give you one example, then you understand why this formula is very, very important. Suppose I'm using a bar, okay, bar. Let the length of the bar is L, and the point of suspension is 1/6 from the top. Find the time period. So let this point is O, this point is C. So first of all, we have to find out OC. From the top, that C is L by 2, and from this it is L by 6. So what you have 6, 3L minus L, that is 2L by 6, that is L by 3. Yes or no? That is the distance between the length between the point of suspension and center of mass. Now, what is the moment of inertia of a rod about the center? We know 1 by 12 ml square. So moment of inertia about the O is moment of inertia about the C plus m into x square. If you remember this, and I hope you all remember, ml square plus m. The distance between O and 6 is এটা কি হয় ওইদিকে নিয়ে গেলেই পুরোটা উড়ে যায়। So m L by 3 whole square. So what we have 1 by 12 ml square plus 1 by 9 ml square. Na? So 9 9 18 12 24 36 36 ml square. 3 plus 4. That means 7 by 36. Now you have all data, so you can use easily time period 2 pi root under, what is the formula? Moment of inertia, that means 7 by 36. 7 by 36 ml square by, what is written here? mgl. So mass is m, gl. L is the length between the suspension point and the center of mass, L by 3. So first of all, in this type of question, if examiner want, they don't give you the mass also. Why? Because this mass cancelled out. Now 1L also you can cancel. So what you have, this 3 is upward. 2 pi root under 7 by 36 into 3 L by G. So 2 pi root under 7L by 12G is that. Okay, understand?
Yes, sir.
Huh?
Yes, sir.
So that's it for today. कल भी तुम लोगों का क्लास रहेगा सेम 10:30 बजे। ओके, 10:30 या हो सके थोड़ा पहले कर देगा 10 बजे। तुम लोग 10 बजे से एक बार देखना, 10:30 तक एकदम श्योर ना। So I'm stopping the recording.